Long before Earth had mountains, oceans, or even a solid surface, it was nothing more than scattered debris, countless fragments of rock and metal orbiting a newborn sun. There was no planet yet, no clear boundary between what would become Earth and what would be lost forever to space. At this stage, Earth was not a world, it was a possibility. In the early solar system, space was crowded and violent. Trillions of rocky fragments, called planetesimals, raced around the Sun on intersecting paths. Some were no larger than mountains, others rivaled small moons. Every orbit was a gamble. Every close pass carried the risk of collision. And collisions were everywhere. At first, these impacts were relatively gentle. Small bodies collided and stuck together, held by gravity and momentum. With every collision, the growing object became slightly larger, slightly stronger, and slightly better at pulling in nearby material. This process is known as accretion, and it is how planets are built, not smoothly but violently. As Earth's earliest core began to grow, collisions became more energetic. Each impact released enormous amounts of energy. Rock melted, metal flowed. Heat accumulated faster than it could escape. The growing Earth began to glow from within. This heating came from three main sources: constant impacts, gravitational compression, and radioactive decay. Every time material fell inward, gravity converted motion into heat. At the same time, unstable radioactive elements embedded in the rock released energy as they decayed. Together, these processes turned the young Earth into a partially molten body. Earth was no longer just a pile of rocks, it was becoming a planetary embryo. As it grew, Earth entered a dangerous phase. The larger it became, the stronger its gravity grew, and the more debris it attracted. This runaway growth meant that collisions became even more frequent and more catastrophic. Some impacts were so powerful that they reshaped the entire body, blasting molten material into space and rearranging Earth's internal structure. For millions of years, Earth existed in this unstable state, half solid, half molten, constantly growing, constantly changing. Yet, despite all this chaos, Earth avoided a fate that might seem almost inevitable. It did not become a gas giant. In the early solar system, vast amounts of hydrogen and helium surrounded the young sun. These gases were the most abundant materials available. If Earth had grown large enough, fast enough, it could have pulled in massive quantities of these gases and become something very different, a mini-gas planet wrapped in a thick, suffocating atmosphere. But timing mattered. Earth formed relatively close to the Sun, where temperatures were too high for light gases to remain bound easily. More importantly, Earth grew slowly enough that by the time it reached significant mass, the Sun had already begun blasting away the remaining gas with intense solar winds. The window of opportunity to become a gas giant closed before Earth could take advantage of it. This was not luck alone, it was physics, distance, and timing working together. Instead of becoming a gas world like Jupiter, Earth remained rocky, dense, solid, and rich in heavy elements. This rocky nature would later prove essential for everything that followed, from plate tectonics to life itself. But how do we know any of this actually happened? The evidence comes from space itself. Meteorites, fragments of ancient bodies that never became planets, are time capsules from the birth of the solar system. Some meteorites are older than Earth itself. They preserve the original materials that formed the planets, unchanged for billions of years. By studying their chemical composition, scientists can reconstruct the conditions under which Earth formed. Isotopic signatures reveal how fast material accumulated. Metal-rich meteorites show how planetary cores began separating early. Others contain tiny mineral grains that predate the Sun, confirming that Earth was built from ancient stellar debris. These meteorites tell us that Earth's building blocks formed quickly within the first few million years of the solar system's existence. They also confirmed that collisions were violent enough to melt rock repeatedly, allowing heavy metals like iron to sink toward the center while lighter materials rose toward the surface. This process, called differentiation, was already beginning even before Earth was fully formed. By the end of this phase, Earth had grown from a loose swarm of debris into a massive, gravity-dominated body, a proto-Earth. It was still far from stable. Its surface was a global ocean of magma. Its interior was separating into layers, and its orbit was anything but peaceful. Earth's size, composition, and destiny were now largely locked in. Every future chapter of Earth's history, the formation of the core, the creation of the magnetic field, the birth of the moon, the arrival of oceans and atmosphere, depended on what happened during this violent growth phase. Earth did not form gently. It was assembled through destruction. It survived impacts that would have shattered weaker worlds. It avoided becoming a gas giant by a narrow margin. And it emerged from chaos as a rocky planet with the potential for something extraordinary. In the next chapter of this story, that molten proto-Earth will undergo one of the most important transformations in planetary history, when fire reshapes it from the inside out and Earth becomes a layered world with a heart of metal and a surface of stone. That is when Earth truly begins to become a planet. Please subscribe to this channel for more interesting videos.